Today we are here to introduce Afterspyre again. This is the second generation. It provides proprietary analytics with machine learning, combining quantitative and qualitative and semantic analysis. Similar to that of a graph database, the inbuilt wizards have a number of use cases, one of which we'll talk about is the organizational DNA. There's ranking analytics for selection of objectives, initiatives, market opportunities, etc. We also have a two-model semantic comparison, which can allow you to compare process listings, for example, between two organizations, features between two software applications, affinity analysis to identify cause and effect, correlation analysis, to give you cause and effect again. So in a typical sample organization, which is multi-business division, you have a large analyst team. In this case, they are mandated to build and leverage the organizational DNA. Typically, the analysts will examine the different elements of the DNA, why you deliver to the market, how you deliver, enablers, what you deliver. All of this goes into the Afterspyre catalog. So there's a discovery phase where you capture all the information. The information in the catalog can be enriched with attributes, which can be from the built-in attributes of Afterspyre, or they can add their own attributes. You can create enumerations for the attributes too, and you can color code them so that they look much better. And why are we calling this DNA? So the analogy is because DNA is made up of base pairs of chromosomes. Within Afterspyre, we have matrix models which have base pairs. So for example, relationships between processes and technology, or risks and technology. And as you can see here on the matrix model, you have a number of these matrices, so a suite of matrices, and these can all become, they all represent the organizational DNA together. These can be created manually, or they can be auto-discovered using the relationship discovery wizard, whereby we can actually import and create a unified catalog from different independent categories. And Afterspyre uses the ability, which is basically semantic matching, to match and merge all of this into the organizational DNA. You can generate and visualize these relationships, and we can actually zoom in to areas of key concern and interest, which I will demonstrate. And of course, the organizational DNA diagrams provide us multiple paths through which we can step through. So you can start from objectives and go to risk, or in our case, we will go to technology to processes. And we can understand misalignments and potential issues. Looking at the next step, we would do ranking with a machine learning algorithm to identify improvement actions and to select things to improve. Again, like we said, initiatives, market opportunities, vendors, and we can visualize this using what we call a four-box functionality. In this case, one of the key issues is to evaluate a build or buy for an expansion alternative. So for this, we would typically compare processes from our organization, the target company's organization, see whether there's similarities, and what we can, whether there are some unique processes which make the target company desirable. So once you run the actual semantic analysis, you will actually see there are 12 processes which can be consolidated, and 21 processes in the target company which hopefully are unique and you want to actually bring them into the acquisition. The semantic and sentiment analysis allows to compare feedback, for example, from our hotel versus customer feedback from a competitive hotel, and you can understand the sentiment of the feedback and understand which one is possibly better. We also have an affinity analysis whereby you can identify, for example, and this is based on machine learning, we'll demonstrate this to answer questions such as which processes based on which location are candidates for improvement. The correlation matrix functionality allow you to understand, for example, again, a process example, you can see cycle time, wait time, transport time, which is negatively impacting efficiency. So these again are candidates for improvement. So like I said, Afterspyre has around 16 analytic wizards as of today. And then we support SWOT, risk management, strategic impact, force field, root cause as examples. We are building these into suites of wizards. So that's on the roadmap. Key benefits are providing quantitative and qualitative insights. You can leverage semantics wrapped in other tools. Robust analytics helping you to draw clear and targeted conclusions. and solving business issues. And of course, we have our inbuilt methodologies. So let me quickly take you through 4 or 5 analytics. That's pretty much all the time we'll have. I'd like to touch base quickly on the catalog of Afterspyre. So the catalog is made up of multiple repositories. So in this case, I have a repository for strategy DNA, 10-year strategy. Each repository is made up of a number of subject areas, and underneath that we have our actual categories and subcategories. Now here, this is a bunch of the technology solutions we have. We have numeric attributes like application score, creation cost, capex, development cost, and so on. And of course, we have here the attributes whereby the analyst can create enumerations and color code and select them. Now, all of these can be either imported from Excel or imported using a web service from any other tool. So it's pretty open in terms of actually getting it in. You can very quickly visualize the data within the catalog itself by using the graph functionality. All of this can be bookmarked and it can go straight into reports. So we'll come to the reports at the end. For the attribution, Afterspyre can define a number of types of attributes, and these attributes can be linked to a project. They can be selected from the Afterspyre built-in template attributes, or you can have your own attributes which could be used across projects. Coming quickly to enumerations, so let's take a single enumeration for technology platform obsolescence. So we can define numeric values for this list of values. These numeric values can then be used in the calculation, for example, high, medium, low, and you can use this for understanding, for example, impact into likelihood and actually doing a calculation. So we do have a calculation engine kind of similar to Excel within the catalog to create all of this results. So once you have captured information in the catalog, you can start doing your modeling. So we have 2 types of models. We have list models. So let's look at the list model for the technology review. The first thing you will see is it looks similar to the catalog, but then you'll start getting your calculation grids whereby you have a number of calculations available on any numeric attribute or any enumeration which has a numeric area to it. Okay. When we come down to the matrix models, and we will take a book purchasing habit. So this is, for example, customers who've bought books. And what you will see here is that the dots are actually either manually put in by the analyst, or we can recreate this matrix from a database. So for example, you'll take a dump from, let's say, an Amazon database, and you can recreate it from here so that you get the matrix model. Now, here you will see that total 700 cells, 192 relationships, and a density of 27%. So, the density actually shows you that, yes, there's a fair amount of data. I suppose when you go to Amazon, you get a very, very sparse density. So we've taken something which really makes sense here, and we'll revisit this matrix model in one of the analytics. Now, you can also create groups of matrix models. So in this case, there's an organizational DNA group, and this is the one I'll use to demonstrate the organizational DNA. So what we've done is we've captured objectives, processes, data centers, database technology, initiatives, controls, risks, and we've auto-discovered all the types of relationships. So in this case, I have a relationship between objectives to technology solution, and this bunch of matrices will go into creating what we call the organizational DNA. So if I come to my DNA relationship discovery wizard, I can first see that these are the start points and the end points. So in this case, we'll say objectives, and we'll say up to technology solutions. I'll define a DNA level of 3, so I can have the depth of the relationships multiplied. So what Afterspyre does is it calculates here. In this case, I have only 5 or 6 paths. Okay, but as I increase the depth, you will see that the number of paths also increase. We then generate the organizational DNA, and what it does is it actually creates the linkages, and I'll just zoom in here. So you can actually see, in this case, I have the objectives which are in red, the key processes which are in green, and the technology solution behind them which are in purple. Okay, and we can actually click on, let's say, my key process marketing, and then you can see all the technology solutions and the objectives related to that. I could follow pretty much any of these paths here, okay? But what we'll do is let's increase the depth here. As an example, let's go down to 5 levels. And let's say I want to go from objectives all the way down to my data center. So which data centers run which objectives? We'll discover the paths. And what you will see that the number of paths increase exponentially depending on the type of let's say relationships you have. And this is a small data set, so it's not a very large data set. So let's take something which I want to see. So let's say I want to see my objectives, to my key processes, to the technology solutions which are here. Okay, so let's find this, the technology solution, the database technology, and down to my data center. So once I run this and I generate my DNA diagram, okay, this actually shows me, all the linkages here within this. And of course, I could play with this and drag and drop it. And below this, we can also see what we call the alluvial diagram. So I can actually look at all my objectives, the key processor, the technology solutions, and in this case, I have 2 data centers you can see. What Afterspyre also does is you can actually look at every single relationship down here on the table, and I can export this to Excel. So if I want to do a pivot table and actually track and trace and follow this, pretty much I can do that. What's also interesting is that as the number of relationships increase, it becomes very important for me to be able to filter this. So in this case, let's say I want to filter out some of the key processes because they are causing a lot of noise and they are not really of interest to me. So here I'll just randomly unselect some of these and then I'll rerun the analysis. So what you'll start seeing is you'll start seeing a cleaner set of data which then becomes available. Now what's interesting here is that I can start putting in numeric attributes. So let's say I want to understand the actual performance of my objectives. For the key process, you want to understand, either the operational risk of the process from the technology solution, the application lifecycle cost, and so on and so forth. And once I start running this, what Afterspyre does is it will start creating, let's say, increasing the size of each node based on the value which is given to them. So it allows you to understand not only the relationships, but you can put numeric context on the relationships over and above that in terms of this. Okay. So this was a bit, let's say, a quick take on the organizational DNA. Of course, there's a lot more to this in terms of functionality, but of course, time doesn't permit that. What I'm going to do is I'm going to very quickly go and show a couple of other analytics. The first one being the sentiment and semantics and sentiment analysis. So in this case, we are doing word and phrase analytics for feedback on a hotel, and this is actually a live case out of Dubai, where I'm from. And in this case, you can see that the feedback for the last, let's say, 1.5 months, that it's a good hotel, it's exceptional, the staff is great, and the sentiment meter has maxed out at 100, and we have a total sentiment score of 473. But when we break down the sentiments, you can actually see the sentiment scores is based on the words, and I can actually sort and see that, okay, there are some negative feedbacks, not everything is rosy. So you can see there's trouble, disappointed, bad. And if I come down further, you will see that the phrase analytics shows that I've done a 5-word phrase analytics. And it says that unfortunately there was construction on the hotel. So typically there was noise which was probably causing some discomfort to the hotel guests. So this is something which was posted on the on hotels.com, the website. We simply imported it and taken it from there. But like I said, we can use this to actually understand the sentiments of what customers are talking about us very, very quickly. And you can either import it directly from a website. So in this case, I've just hooked onto my local site, or I can actually put in text data directly into here, or I can actually analyze the data within the Afterspyre repository or catalog or a model. Okay. So this is a bit about the sentiment and semantic and sentiment analysis. The next analytic I'll show you is the 2-model sentiment analysis comparison. So we spoke about the acquisition where we are talking about the processes of our company, and here we will look at target company processes, and then we will look here for our existing company processes. Okay, so the existing processes and the target processes. We can do a fuzzy compare, so in this case I've taken an 80% threshold. I'll run that, and here you will see that, again, this is the same screenshot. We have 12 common processes, 36 processes of ours, which is here. We have 21 processes which the target company has, which we don't have. And here we have, as you can see, there will be 12 companies. There's HR, IT, finance. So these are common processes. So these are the ones you could probably consolidate in a sort of a merger. Okay. The next analytic, which I want to very quickly show you, is the matrix affinity analysis. I'll quickly do the attribute ranking for that. So we spoke about ranking analytics. In this case, we are doing a technology review. So we want to rank the technology we have, which you saw in the catalog and in the model, based on the application score from high to low, the operational risk from low to high, and the technical risk from low to high. And once we actually run the ranking, we can see that in this case we have payroll, which is the highest rank. So it's got the highest rank here. We can rerun this by actually, in this case, I'll put development cost, and I will say, for example, from low to high. So you can actually rerun the ranking multiple times and then compare. So in this case, I have production planning, but then I can compare the results here. So based on the different runs what we have, we can compare the results. And of course, we can visualize that in a 4-box. So in this case, I have the two risks, and you can see that here these are the applications which have the highest risk at the top here. So now I'll come into the matrix affinities analysis. So again, here what we are doing is based on machine learning. We are looking at let's say book habits. So these are the customers, and these are the books they've purchased. Again, this is built backwards from the database. The row frequency, the column frequency, and here typically, and Frank, maybe you can step in and we'll do the lower one first, where we talk about.
Let's start with the bottom one first.
Yeah.
I've managed to maintain my silence all this time watching this, but and I'll make a few comments about some of the other analytics also and how they're used, because these are very simple cases.
Yeah.
I'm sure. Did you scroll all the way to the bottom on this one? Yeah. Okay.
Yeah.
Further down. Okay. If you see twisted prey here on the bottom, those of you can see it, you look across here and you'll see the affinity ranking, and that's pairing the twisted prey with something else, with another book. It says, do you remember from Amazon, people who bought this book also bought that book? This is how you get that number. So you take this row here, and you rank the row with the highest affinity, and that's the book you put to the left, because we read left to right. If you're in other countries, you might put it right to left. But that triggers the eye to look at the next most popular book that's bought together, okay? And what you will see out of this is how you get your ranking. Now, I want to make a point here that Jude went over earlier. This particular matrix has 700 cells, and it's, I believe, 35 or 36 by something to get that. 20, I think it is. 35 by 20 to get the 700.
Yeah. So
also, the density is very high. I did it deliberately so I would get good affinities here when I created this one originally. But what I want you to think about is take a look at Amazon and ask yourself how many customers they have. 100 million? 200 million? Then ask yourself how many books they have. 20, 30,000? Then ask yourself how many cells that matrix has. And what you'll see, and this is true, and it's an issue in doing this type of analysis, is that their density factors are like 0.0001. It's almost empty. So there's a lot of stuff that goes ahead of this to collapse down that matrix into something that is computable very rapidly. Okay, they do it that way. But it's interesting, everybody can understand this one, but what they don't see is what's up here. Now these are the people who are buying the books. And if you're someone like Amazon, this may or may not be terribly interesting to you unless you have profiles on them, which I'll go into in a minute. But what this would be interesting to is someone like a library. Why would a library be interested in this? Because if I have two people who are reading the same kinds of books, they might be interested in forming a book club, which will increase my usage of the library, which is what one of their goals is. But people don't usually think of what the other uses of an affinity matrix could be. They tend to look at one side or the other. And that's a pretty interesting one. Affinity matrices, if you do research on them, which I've done a fair amount of, they go back a long ways. They're primarily used in marketing. Probably 90% of the hits are going to get are from marketing. People of this ethnic persuasion bought toothpaste and mouthwash together. People bought cigarettes and breath mints, which is a famous one, together. That's why they put the breath mints by the checkout counter. Because you bought cigarettes and you suddenly realize, I got a date, I'm going to get breath mints. I'm serious. This is very basic. The people who know the most about psychology are in marketing, especially retail stuff. They really know buying habits and stuff like that. Do you want to go to correlation?
Yep.
Okay, let's go there.
So this is pretty much the last analytic I'll have time for.
Okay.
So we'll very quickly go to the correlation matrix. And here we are actually running an analysis of US mortality rates. So a bit morbid, but yeah.
Okay.
Okay.
Can you expand that out a little bit?
Yeah. So
now you'll notice how this matrix is pretty empty, and you'll notice that this is the diagonal is going to be empty, and this whole upper half is empty. And if you know anything about this type of a calculation, you realize it's n squared minus n over 2 tells you the number of items you're going to get in the matrix. So they're all down here, and the reason is it's a correlation matrix. This is the same as this. That's where you get the n squared minus n over 2, and n is diagonal. So you take a look at this, you want to find out which things are most highly correlated. And chances are those things will occur together. Correlation matrices like this are used as the first step in trying to find cause and effect. Correlation is not cause and effect, but it oftentimes will lead to cause and effect. If you have no substantial correlation, you're looking in the wrong place. That's what it'll tell you. And you can find things with high correlation, like the total number of dead people in respiratory is pretty high, stroke is pretty high. Yeah. But you'll find what you're really looking for.
Heart and cancer is pretty high.
Yeah, you're looking at things that go together, like cancer and heart disease and stuff like that. This comes from real data, right?
This is real data. Yeah.
Yeah, on a particular area of the world.
Yeah, this is from the US.
Yeah, it's from where?
From the US, yeah. So
this is from the US.
From the US. So typically what we've done is we've again plotted heart and cancer, and we've got all the states here. So the size of the bubble is basically the sample of what was surveyed in terms of let's say the total number of deaths. Let's put it that way.
You see a nice interesting pattern, don't you?
Yeah, exactly.
Of the states. I mean, you can see who's got the highest ones, who's got the lowest ones of cancer-heart combinations.
And you can very quickly change this, so in this case you want to see heart and diabetes, you can very quickly change it, and then you can see there's not so much of a direct correlation as there was between heart and cancer. So typically Afterspyre allows you to do, advanced analytics using very simple, loads of data in, and from this point of view, we can actually, like I said, bookmark all of these, put this into reports, and not only can you have the report with the analytics, but you could also put in the context on the report. So if I actually just quickly open up a report here, you can actually, within the report, put in images, you can put in really, hyperlinks. So this really becomes your management report. And in the report itself, you could actually use the analytics. So I could actually drill down here within the report while I'm presenting on this, or for example, remove some of or deselect any of these things. So that's pretty much what I wanted to show you very, very quickly. I'm open to questions, and so is Frank at this point of time. Yeah.
What are your top 3 uses by customer? I see a lot of potential.
Yeah.
But I'd be interested to see what you're
So if I look at the top 3, one is ranking. So ranking gets used a lot for, let's say, selection of, let's say, budget funding. So I want to do a lot of initiatives. I want to understand where the money is going. How do we rank it? Technology selection, vendor selection. So this is one of the key uses. The second key use is basically, especially in the region we are in, is the organizational DNA. So really what they want to do is they are bringing out 50-year plans, 100-year plans. And what they want to do is they want to blueprint the technology, what they are trying to do, the objectives they have, the types of risks they are going to have, and try and understand the relationships, a bit like what you do with AutoCAD on paper before you actually go and build the building and find out the doors in the wrong place. So they want to blueprint the enterprise before and blueprint it on a long-term basis. So that's where this is being used, put in things like the risk scores, the possible performance scores, population numbers, and these are really the two top analytics which are being used. The semantic and sentiment is again another one where there's a big use case.
I think if you take a look at this, it depends on who the user is. If the user tends to be an analyst or a consultant, they tend to work across a lot of the quantitative analytics. The managers are there also, but if you're in like marketing or sales or something like that, you could be big into this sentiment analysis, because one of our clients now is using the sentiment analysis in the following manner. They get from social media a sentiment value or a keyword listing, for example, and they'll get internal one from their customer service, and they compare the two to see what the sentiment is of the company outside the company and what the sentiment is of the customers who buy stuff from the company. So they can compare the two and see if the image is different or the same. They're also taking a look at the internal parts by doing some simple sentiment analysis across emails and stuff that tells you what the internal employees think of the company, which is really interesting. So they can see where they have to put an effort to improve their image of the company. This is mainly done by companies like telcos and things like that, who have a reputation that they have to maintain in customer service. And the correlation analysis, for example, is done by telcos also, because most telcos keep 50 to 100 characteristics of their customers. And they know by the demographics, for example, that people in the age of like 20 to 29 will buy these pairs of things together. So they make a marketing program to promote those to that particular age group. And this is proven to increase sales as much as 30 to 40%. It's really a powerful technique for understanding what type of things you want to present to your customers. So it depends on what type of position you have in the company, where you find the most value in a product.
Another interesting...
I'm sorry.
Sorry.
One of the more common things that analysts use it for, particularly process people use it for, is when you have consolidation of processes internally. For example, you have 6 of the same purchasing processes. You want to find out how to consolidate them. Or you're going to do a merger, an acquisition, or even a divestiture, because you could use this for divestiture to find out which are your most tightly integrated processes that you have, and you're going to have to split them across or copy them into whatever you're spinning off or selling. So the semantic aspect of this becomes very important. I don't know if Jude pointed out, I don't remember, that when he showed you the alluvial, okay, and that's all done semantically. Okay, it's all with semantic analysis. So that makes it fairly powerful, and the fact that you can follow a chain like that allows you to, and then you can modify it, allows you to narrow in on a problem very quickly. Okay.
Yeah, so again, one of the other pull use cases are especially in our region, is the selection of AI. So they are trying to look at, again, so what are the possibilities for AI? What are the things which AI can benefit? And it's all greenfield, so everybody is just throwing stuff on the wall and seeing what sticks. So
yeah, well, what we're looking at now, and have a proposal actually out now to integrate the outputs of the analytics here with inputs to decision structures, particularly influence diagrams, where you also have things like probabilities and everything else that for decision making, a little bit different. And we look at that as a vertical view of analytics on applying AI to an organization, as opposed to a horizontal view where you're looking at a lot of machine learning things to be able to augment your processes and improvement through that aspect of AI. Deep learning is a little more difficult to implement. First of all, most people don't understand it. You can't go in and talk to an executive about a convolutional net. They'll throw you out of the office. Just that quick. Okay, so you have to be very careful about how you present some of this stuff, particularly the AI stuff. I am very much concerned that we don't damage it like we did with knowledge management and a few other things in the past, where we oversold it.
Okay.
Anything else? I mean, we'll be around for wine and dinner. So.
Good. Frank, Jude, thank you very much.
Thank you.
Well, that concludes our first day of at least our prepared program. So now we have the wine reception and dinner upstairs. The wine tasting as I said. I only get so far before I get into antisocial behavior. Wine has been a theme at BPM Next.